engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow. Growing demands, evolving expectations, and limited resources. These new realities are creating unprecedented possibilities for architecture, engineering, and construction companies. Technology is helping them to work more efficiently and more responsibly, to build cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured multidisciplinary data from planning and design to building and operations. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project lifecycle and sets the stage for future projects. This is BIM. It's the foundation of a digital transformation in the architecture, engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow. Growing demands, evolving expectations, and limited resources. These new realities are creating unprecedented possibilities for architecture, engineering, and construction companies. Technology is helping them to work more efficiently and more responsibly, to build cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured multidisciplinary data from planning and design to building and operations. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project life.
A very good afternoon to everyone. This is Abhishek Mukherjee. I am a BIM specialist architect at Capricorn Technologies. Warm greetings from Capricorn Technologies, and I welcome you all to this webinar, which is called Digital Twinning of Buildings. And along with Mr. Nazim Khan, I am going to start this presentation without much further delay. So thank you for joining us today. You may put your questions on the question and answer box anytime during the webinar, and our eminent speakers will answer them in the Q&A round. Kindly do not hesitate to ask questions. You may ask several questions related to the topic of discussion today. So let me give you a brief about the speakers and the agenda for today. So after a welcome note by Mr. Chakresh Jain, who is the chairman Capricorn Technologies, we will have Mr. Vasudevan Suresh, the chairman IGBC and president of Focus. He will be explaining a bit about significance of digital twinning. After which Mr. Ashish Rakheja, managing partner at Aeon, will be explaining about the application of digital twinning in the real world. Then followed by Mr. Sachin Fulsundar, Technical Solution Manager at Autodesk. He'll be explaining about using CFD analysis for design validation and optimization. And then finally, Mr. Nazim Khan will be taking a session on how to use Revit and Autodesk Insight for building analysis. So Nazim, I would like to ask you to take a poll of the participants' background.
Okay, thank you, Abhishek. It was a great welcome. I'm sure that all of us are very excited for the webinar. It's the topic is very relevant, and the industry, the speakers that we have, they are the expert from the industry. So I am very excited. I'm sure that you are also very excited, Abhishek, right?
Absolutely. And me being an architect by background, and I also have a master's in building services, it is really a learning experience to hear from such eminent speakers here who will be giving their presentations. So,
Fine. So,
Nazim, sir.
yes, sir.
Yes, you
So,
may continue.
yes, okay. So I'll run a poll, and because we need to understand, I'm sure that we have a mixed crowd from all the backgrounds. So to be able to bring the more relevance to our webinar, we'd like to understand what kind of audience we have. So this poll is going to ask the question related to what background does our audience belong to. So let me just share the poll. Just allow me a second.
Nazim, we are not able to hear you.
Yeah, only visual is there.
Okay,
Yeah, Nazim.
Yes.
Yes.
I think there is some issue that I'm facing. I think we can take the poll afterwards. So I would like Abhishek to continue. Please, Abhishek, can you continue from
Yes, sure. I think we'll wait for other participants who are also in the process of joining, and then we
Right.
can continue with the poll. Yeah.
Definitely.
We are across 100.
Yes. Absolutely, sir. So next slide, please. So I would invite Mr. Chakresh Jain, who is the chairman of the board at Capricorn Technologies Private Limited. He did his architecture from IIT Kharagpur and started his AutoCAD training and consultancy just after graduation. So over to you, Chakresh sir, for the welcome note.
Yeah, thank you, Abhishek. So first of all, I'd like to thank all the participants for coming and attending this webinar. We know all of us are going through probably the toughest time we have ever faced in our life. And has been said that it is a 100-year pandemic. And this week, especially, we unfortunately, a lot of bad records or the worst records are being created in this area. But I think this also highlights the need for the topic which we are actually covering today, that how can we live a more sustainable life in general. And what we are discussing is by and large in that area. So I like to thank Mr. Suresh and Mr. Ashish and Sachin for coming, and I'm sure we will get enriched by your wisdom and expertise which you are going to share soon. So I'll not take much time. I'll just take 1-2 slides about Capricorn, and with that I'd like to hand over back to you quickly. So just Abhishek, if you could move to the next slide. So as an organization, we have been serving the technology solutions for, especially for the construction industry, since 1987. And today, with all the effort which we put in for so many years, we have more than 20,000 customers like yourself, and whom we are serving through our 250 strong team across the country. So we are Autodesk Platinum partner, and apart from construction, we also are Autodesk partner for manufacturing, multimedia, and other solutions. And we are governed by the board members as what you see on the right side. Abhishek, next slide, please. And apart from Autodesk solution, we know that as a user, you also need some more solutions. So we have tied up with relevant companies, and we provide holistic solutions to all our customers. That's what we attempt to do, and we'll be more than happy to have any feedback to improve on that. So with that, Abhishek, I'll hand over back to you so that we have more time to hear from our experts.
Thank you very much, Chakresh sir, for the welcome note. And now I would just give an introduction on Mr. Vasudevan Suresh. So Mr. Vasudevan Suresh is the chairman of IGBC. He is the president of Focus Forum of Critical Utility Service. A civil engineer from Anna University with 54 years of professional experience in housing, infrastructure, rural and urban development, real estate development, and built environment sectors leading to sustainable development. He is a fellow of the Institution of Engineers India, Indian Plumbing Association, and Royal Institute of Chartered Surveyors, that is RICS, senior fellow of Indian Green Building Council, honorary fellow of Indian Institute of Architects, Institution of Public Health Engineers India, and Institution of Fire Engineers India. V. Suresh is vice chairman, National Building Code of India, and chairman, Housing Sectional Committee, and member, Smart Cities Committee of BIS. He is the member of International Property Measurement Standards, Standard Setting Committee. He was president of Indian Building Congress and NAREDCO, vice president, chairman, vice chairman of CIDC, and vice president of AIHTA. He had represented India and worked closely with UNCHS, UNIDO, UNDP, SARC, ADPC, ADB, KFW, World Bank, ODA, and JBIC. He is a strong advocate of sustainable development and passionately pursues disaster-resistant, environment-friendly, ecologically appropriate, and energy-efficient options in built environment and the green building movement. He is the chairman of IGBC Policy and Advocacy Committee. He is actively associated with institutions dealing with professional education in built environment sector and also for skill development initiatives. So, sir, without any further delay, I would hand over to you, sir, for your presentation. Thank you.
Thank you so much for the very detailed introduction. So let me greet all the distinguished participants for this wonderful afternoon session, post-lunch session on the digital twinning. And special welcome to Chakresh Jain, Ashish Rakeja, my colleague in both IGBC and Focus, and Sachin Fulsundar, and Akhilesh as well as Nazim Khan. And of course to Abhishek, of course, very happy that introducing all of us in a big way. We are all meeting at a time when the whole country and the whole world is going through 2-3 important things simultaneously. Of course, the biggest thing that's coming over is a COVID situation, a pandemic situation. We're all depending upon the whole thing to come down in a better way so that life starts and goes in a smooth manner, and we are able to create healthy environment for all of us, healthy built environment. It has got various dimensions of that, but then the most important component is trying to create the buildings and the infrastructure at the city level and all level in a very conducive way, which will be good for the humanity, for all activities to get together. So be it the office space that we create, or the residential space, or spaces related to recreation or education or health facilities, whatever be the building, whatever be the asset class of building and the infrastructure, has got to take care of this particular thing. And it's also a time when India is also going through a major demographic explosion from just around 1 billion or 100 crore in 2001. We're already about 1.4 billion or 140 odd crores population, adding as much as 40 crores in about 20 years time period. It's no small joke. India was only 32 crores at the time of independence in 1947. It took 5,000 years for coming to 32 crores. And now 20 years, we're adding 40 crores, adding at the rate of 2 crores every year. That's a phenomenal development aspect. So 40 crores getting added means you are thinking in terms of over about 8 to 9 crores of new families coming in, so much more additional housing needed, jobs needed, schools needed, hospitals needed. Everything is in a quantum level that's required. Only thing is the speed at which you are adding that is much slower than the speed at which the population is increasing. We'll be touching of the order today. If urban development, urbanization is of the order of around 55 crores, we'll be around 60 crores population level in the urban areas alone. That will be around 40% urbanization level. So 60 crores of urban population of 28 crores in 2001 is a doubling of the urban population. And that's where the engines of growth and economy in a large way. And at the same time, you got to see how best you will deal with that particular thing in an efficient way, in an economic way, in an effective way, which are environment friendly, ecologically appropriate, and energy saving. Not very easy. How best you use all the resources in an optimal manner. Land as a resource, building material as a resource, energy, water, etc. All our resources which are coming over there in an optimum way. And therefore, we are at a time when all this development need to take place, and that will take place in a speedier manner. How do you also optimally use all and efficiently use the resources becomes an important component. And hence the whole approach towards the whole sustainable development aspect to come in a big way, and the birth of green building movements in different parts of the world. Maybe in UK it started in somewhere in the 1990s, the USGBC somewhere in mid 90s, and IGBC started in 2001, and about 20 odd years we have been doing, and we have about 70 odd green building councils in different parts of the world. We are part of the World Green Building Council. We are extremely happy that yesterday only on the World Earth Day, we launched the phenomenally impactful event called the World Earth Day, and we got the net zero mission launched by IGBC for India, along with the World Green Building Council CEO yesterday. So we are part of that big movement, and we have done a reasonably good way in the context of what's happening in the green building movement in the whole world. We are nearly number 2 at this point of time. In the last about 20 years time period, about 7.77 billion square feet of green footprint, or 777 crore square feet of green buildings is coming, and that's a phenomenally large number. And through about 28 ratings and all asset class of building, and not only building, but building with the built environment, covering buildings and the infrastructure space around that. We were again the first one to go in that sector to cover the built environment space, not just buildings alone. And therefore, this has taught us phenomenally good amount of lessons over the last 20 years, and it's very necessary not only to plan and design and construct buildings, but also complete it and ensure that the buildings are also performing very well, not only on paper of design intentions, which many people do that at the time of submission of the project report. I'll say so much energy, so much water, so much waste reduction, etc. This will be my performance good point of view to get a platinum or a gold or a silver or a certified building under any category. But we have to also ensure that performance as challenge of the build aspects of buildings are also equally. And that's what the taste or the value of any food that we eat, it depends upon how well people have taken that particular one. So keeping that in view, proof of the pudding is in the eating finally. And therefore, The performance challenge initiative that took over last few years' time is a very major initiative in the built environment, where all asset class of buildings that has been certified, and how do they really perform? And this is why are we doing this particular thing? Because that's what the clients want. That's what the residents want. That's what office space want. That's what IT park owners want. That's what data center owners want. That's what the hotel industry want. That's what the hospital people want. How does it perform in the best possible way? And we have done a fantastic job by getting this particular performance challenge to objectively measure the performance of these green buildings, facilitate performance improvement on a continuing basis where that's needed. And we're also happy that this is at a time when the National Building Code of India 2016, I'm the vice chairman of that, and I'm very happy that we got this chapter on part 11, which is called Approach to Sustainability added, where life cycle costing has come into a big way. The performance of the not only the design, construction, but completion, commissioning, occupation, and how do they perform over the next full life cycle of that particular building, 50 years, 60 years, whatever, or maybe you may not get the same life cycle for maybe services, maybe structural, non-structural finish and services with a different life cycles coming on that, how to deal with those particular aspects. So facilitating performance improvement becomes an important aspect, and that can only be done by operating and maintaining right. There again, good enough that the new part on National Building Code part number 12 got added, where the first building code in the world again, even part 11 is the first in the world after the Sustainable Development Goal to the 2030 came. India was the first one to add the chapter on sustainability, which is part 11, which I just now told you, where the life cycle costing and life cycle assessment came in a big way. Part 12 is very important because assets and facility management becomes an important component. How do you ensure that everything works? Air conditioning is working, lighting is working, plumbing is working, lift installation is working, firefighting installation is working or not working, and are they doing optimally, etc. And we got that added, because still now all are happy. You plan, design, build it, get a completion certificate given, get an occupant certificate gone, architect gone, builder gone, engineer gone. It is only the users which will be available to take care of the baby, is it working or not. So that part was also helped over there to ensure, how do you ensure that the buildings are continuously being maintained, and therefore the assets and facility managers come in the picture to measure performance, and therefore facilitating performance improvement and performance benchmarks for various building typologies becomes a very, very important aspect. And we are seeing how best to get this done so that the benefit goes to the opportunity to enhance the green performance on a continual basis, learn from renowned experts and experiences on what are the new changes that will be required, or what is needed for the best performing buildings, or national recognition can be given for those well-performing buildings as well. And we cover on all the aspects there, be it on energy benchmarks for building typology. Energy as a very major component is important, because we are also tying up with all our rating system linked with not only the National Building Code of India, but also the ECBC Energy Conservation Building Code, Ministry of Environment, Forest and Climate Change, their regulations, as well as the Renewable Energy Mission area spectrum. So with respect to that, energy benchmarks, we try to do that. What is the energy performance index coming on the building, on the amount of the energy being consumed for square meter per year for different building typologies, for IT or ITES building or office building, or either for the daytime one or a 24 hours working system, or a hotel building, another institutional building, for different climatological zone for the country, being a composite or warm and humid climate, or hot and dry and temperate climate. For each one of the values are identified. And what is interesting is that all the IGBC certified buildings have demonstrated at least 20 to 25% lower consumption than even the ECBC norms. So that's a good creditable aspect. And similarly, on the benchmark on water efficiency, which is another important. Just incidentally, energy performance is a very major thing. Roughly around 35 to 45% energy saving is what the IGBC rated buildings do bring in. And on the water side, roughly on 25 to 30% is the type of water saving that we come than a conventional building. And then here again, the per capita water consumption per day is identified for all these types of building typology. We put certain benchmarks there, then try to find these buildings, where do they really stand with respect to that. And here we are able to see that this is at least 25 to 30% lower than even the uniform plumbing code norms which are there. And therefore, these benchmarks norms are very, very important. And we targeted all types of buildings, not only residential, non-residential, including industrial, commercial building as well as transit buildings, airports, metro, railway. We got ratings incidentally for that. I forgot to make a mention. In addition to buildings and the built environment, which will cover cities rated, township rated, campus rated. We also have all the mobility component of space for airports, railway stations, metro stations also coming. And latest is, of course, the warehousing component also added. And when we try to do that, weightage based on energy performance or water performance or waste management performance in large way, we find the type of importance factors that should have been taken into account, either at the planning and design stages by the whole team, design team, the architect, the structural engineer, the civil engineer, MEPF engineers of different background who are going to give inputs on the HVAC design or lift installation design or the illumination design or lighting and other related design issues and fire protection design. Everybody has to put their thing properly. Now, this is the most important thing. The digital twinning comes into a large way because if all those final outcomes are required, you got to think of each one of the small slices, either at the design stages in a large way, and therefore we got to see how we get good benefits of the digital twin aspects to be brought in at this team level. How much of the 130,000 architects in this country and about 10.5 lakhs of civil engineers and roughly around 5 lakhs of the MEPF engineers of the country are fully aware of that. I would say around 5 to 10%. That also is a stretched out figure, it will be still lower value. So they haven't utilized that in the right way, and coordination, integration becomes a very, very important aspect so that you are able to really get the benefit of the digital twinning issues in a very large way, either in respect of the coordination between each one of the input producing team members in a large way to be incorporated, as well as virtual simulation of the higher building quality and performance, right, even before you would have started doing the particular project. I'm sure Ashish will be able to give, I'm sure in his examples, how we are doing it. And also, as per the system, the speed of construction becomes an important thing. Assembly, products, prefabrication or precast or pre-assembly and institution, fewer accidents on job sites. A virtual modeling for conflict and error detection becomes an important component, very important. And let me tell you, there's a phenomenal competition in the XYZ space in a building horizontally and vertically floor-wise for each one of the services to occupy. So where do you give in that particular thing, each one fitting the right way, where each of the consultants or the specialists on critical service will play a role. And incidentally, that's where, not to take up a tangent, but I thought it's the right time for you to know that there's a good organization which has been born 6 months back on the 26th of October, called the Forum of Critical Utility Services, and that contributes to more than 50% of the construction cost. It is not the structural, non-structural, and finish item which is taking place. The remaining component, there's not been so much specialists are there, so many industry people are there, and that's where you got to put it all together and in a whole on a building space. And when you do that particular thing, you got to see the conflict and the error detection becomes an important component. I'm able to see digital twin playing a phenomenal role, especially with all the consultants coming. Imagine the gentleman who's dealing with the project implementation at the site level, the whole engineering project leader over there with all the specialists dealing with the civil construction, mechanical, electrical, all the plumbing, fire protection, each one come at different stages over there. But you got to think to the last of the details of nail for the particular project if it's a good, well-implemented project. And which will also ensure that no data loss comes on that. Transparency will be there for idea to rebuild in a full manner from concept to construction to completion and commissioning. All the four are important. And how do you deal with that? It's a collaborative design. Higher building functionality will come when you interact with each of the particular team members together, different layers of the drawing, one above the other. When you do that, I myself have done one of the major particular projects over there for one of the leading builders of the country for big township projects, both in Hawaii as well as in Panvel and Chennai. I can imagine the amount of benefit that this has given. And most of the infrastructure, not only within the building, even the external infrastructure where the utility duct has to be provided with all the infrastructure to be put space for everything, a place for everything, everything will be in its place. You know, that type of approach coming on that, and collaborative design becomes an important component. And then normally when you do that, you will have less and less amount of change orders coming on that, change in specification, change in design, and therefore you can have budget reliability coming, cost control becomes important thing, your time overrun, cost overrun becomes much, much lower when you work up to the detail. I'm aware of two types of projects. I dealt with both of them. One where you had about 3-year time overrun, another where no time overrun. We did it a few months even before the completion date. I can tell you with a sense of happiness, the difference is phenomenal. And wherever we have gone such minute detailing with using the BIM and the digital twin model in a very large way, that's where the success has been phenomenal. And I tell you, it has also helped all the concerned delivery system. I use the delivery system because the building construction team over there, the infrastructure delivery team, each have to work in tandem there. And therefore, you're also able to get better data quality out of that. And that brings in a whole life cycle building management system. And if you do all this in the right way, you are building an ecosystem in India's AEC sector. And that's an important component in architectural engineering construction sector. At the 3 level, I'm holding that. It will be at the policy field level and also at the process field level and the last and most important technology field level. Let me open out a minute for each of these particular 3 levels. What does it mean, the digital twinning for the sector? Number one, for the players, the regulatory bodies, education institutions, the approval groups which are coming over there, and they're also going increasingly digital, by the way. And a large number of municipal corporation municipality out of the 4,314 municipal corporation municipality, you should be very happy to know online submission of the building plans or approval has happened 2,212 already. This is a very major initiative coming. How can you submit all these particular drawing, not the 70 sheets of ammonia prints or blueprints over there? All you can give it just by giving it on digitally, the whole thing can be submitted, processing can take place. So to the regulatory body giving the approvals on that, it will become important thing. And also for the funding institution and also insurance companies who are dealing with these things, including the regulators like RERA or whatever. Education institutions become an important component, architectural engineering schools in a large way, and educational, the young groups which are coming out who have never been trained into that. You got to also get the new young team to be also dealing with that in the right way when they get into the new office the moment the graduation is over, very importantly. At the process level, owners, operators, project managers, architects, engineers, developers, contractors, suppliers, fabricators, facility managers, estimating, quantity surveyors, and all of them will get phenomenal amount of advantages because they're able to get excellent good for construction drawings, the right quantities, and through BIM models will be able to get you all these components in the right way. And wherever you get those details, ladies and gentlemen, that's where we're able to ensure the biggest impact. Obviously, technology becomes a very, very important thing. You can't do the way we used to do 50 years, 40 years, 30 years, especially the large number of India's projects required. We got to build double of what we have so far built in so many 2,000 years in the next about 20 years time. That's the way the population growth and the demand goes. So the speed becomes an important component there. And therefore technology to deal with that, besides the building and other technology, is also going to the technology in this particular sector. The BIM, the right level of software to be adopted. I'm happy to hear Chakresh identifying the various 11 players whom they are utilizing. And it's good. Of course, there are leaders in this direction who are already setting standards, world standards. And Indian industry is also growing up to that particular one, including in the drawing offices, as well as the deliverables coming in the sector. The database technology is equally important, and graphic information systems, very important for the monitoring area, as well as the equipment and peripherals for all communication system. And this is the most important thing, communication, especially if you want on a good planning schedules coming on that. Any amount of delay coming at any point of time, what type of changes to be done immediately in that to set right any delay that has happened is a very important component. And therefore players are going to be software developers, hardware developers, and network providers in a large way. So it's a combination of process, policy, and technology fields together, working together, that will make a major impact at the level. To me, it's going to be, if you want to support Indian AEC sector organization in a big way for delivering the digital twin, 3 major areas to work are the technical, managerial, and strategic inputs. And all the 3 have got to put their acts together. And that's when it comes. And take my word, those leading builders and developers, worth its name, I would put maybe of the order of less than 10 in the country, with all capabilities identified at the level of planning design stages as well as construction stages, the best possible construction companies coming over there, best possible services, installation companies, service providing companies to be added. Normally, it always comes with that. The best one also takes the best architects, best MEPF team, best consultants team, and also the best delivery team also to work in this particular area. And they always have the asset and facility managers. And I was really very happy. Let's go 4 years back. The AFM team identified right in the beginning. You would not have even thought of doing that particular thing maybe a few years back. And therefore, they know if it has got to be maintained, let's get the ideas from the AFM team right in the beginning so that they incorporate. Safety, security, and other related issues also come into it in a very large way. And therefore, it's very necessary that when we are dealing with this particular theme, we'll have to see how we deal, understand the significance of the digital twinning components to be brought into the AEC sector, and how it's going to contribute not only for the green building movement in a large way successful, which any case they're using. And most importantly, now you have the right level of BIM models that are available, and you also have the best building management system. BMS system is very, very important if you have to really measure the performance of the building over there. We have done it in for various things, not only for competition purpose. Even good builders and developers worth their name. They have good BMS system with central control room to identify 24/7 the way in which each of those things on the air conditioning system or the blowers or the water efficiency or the way in which waste management, other related things are done are all monitored in a very good way. And therefore it'll all be to the good of the overall project. And besides the design stages and passive and active design, you would have got the savings which are identified of the order of around 30-40 level for energy or water about 25-30% level. Now we also got into the new model. I'm sure Ashish may be touching on that, on the net zero movement, or net zero energy, net zero water, net zero waste, and net zero carbon. After all, the net zero mission is where the whole world is moving forward. And you saw even America, which withdrew 5 years, they come back now. Yesterday, the US president has given the particular clear-cut this thing that how much reduction they're going to bring down as far as the overall carbon footprint component. India, good enough to achieve about 35%, would have been good for 2005 level. We are nearly done about 22%. And they said about 52% they're going to bring. US, of course, for all the guzzling, we are taking only 5% of total requirement contribution to carbon footprint India, but others, the developing countries, have got much more. So what I'm trying to say is all of them are finally leading to a good end result. If you want to measure economy, if you want to say environment, if the ecology, and all these impact producing one for good quality of life and sustainable development model, if you have to do, I am a totally, what can I say, supporting the whole initiative that we need to do along with the BIM initiatives as well as the twin partner initiatives that we require, digital twin partners to be identified and introduced in a big way. And those who have done it well have always used that. Let's try to learn from that best practice. I want to give my best wishes for Chakresh to take a theme of this nature. Is already receiving substantial amount of understanding. Even under focus, we have an exclusively separate particular group as a vertical to deal with this particular aspect, along with other verticals of various services, critical services. I just thought I'll indicate because there's a lot of opportunity for us to work together, both within the IGBC sector as well as the focus sector. Thank you very much for the opportunity given. I'm talking extempo, so I'm not sure whether I kept the time or not. I must have taken slightly more. Excuse me for that. Thank you very much.
Thank you, sir. Thank you so much. It was really full of information, and I'm sure that we all have benefited for a lot of information that we got from you. And it's a long way to learn. And I would like to, it's an honor to have you on the session. Thank you so much. This is just to make a note to the audience that sir has taken out time out of his busy schedule, and he is not going to be available after 3:45 or 4 o'clock. So I would like everyone to post their question. Please feel free and do not hesitate. Post your question as much as possible in Q&A session. The moment Ashish sir will finish his session, we'll take questions. in the break. So before I move on to the other speaker, I would like to run the poll and would like to hear from the audience what kind of audience we have. So this is the poll in front of you. Okay, so a lot of participants have participated. I would like to urge other people also, if they have not participated, kindly participate. We'll wait for 3 more count and then we'll end the poll. There are some people, 72% of participants have voted already. I'll end the poll. 98, 73, it has 74 now, still increasing. 75. Okay, fine. So we see a lot of people. The majority of the participants we have from architectural background. We have 36% of participants from architectural background, followed by MEP engineers, 29%. Then we have structural engineers, and we have students also, PMC also, and 17% belonging to other group. So thank you so much for the participation. This is going to be helpful to other speakers that we have. So next speaker, I would like to, I'll share my screen.
Any problem in the?
I'll just share my screen. I hope my screen is visible now. So the next speaker that we have, we do not need an introduction, but I'm honored to introduce our speaker. And so our next speaker is an icon. He's a legend, and he's influenced a lot of people in the industry, and including me as well. So I would like to introduce Mr. Ashish Rakeja, sir. He is going to speak on the application of digital twinning. And Mr. Ashish Rakeja, sir, is a partner at Airborne Consultant and has a postgraduate degree in thermal engineering from IIT Delhi with over 28 years of experience. He's a seasoned consulting engineer who has designed more than 2,000 projects, including all kind of projects, including hotels, airports, hospitals, retails, residentials, commercial, high-rises, and industrial projects. He specializes in high-performance building and has been actively involved in leading design activities of electromechanical services for 10 net zero energy buildings and over 60 platinum-rated green projects in India. Mr. Ashish Rakeja has won many awards and has delivered over 1,000 talks on various facets of building design across the world. He's an active member of over 20 technical societies, including the fire societies, BMS societies, other services societies, and regularly contributes his time on writing standards, codes, and position papers for government bodies and technical societies. Mr. Ashish Rakeja, along with team of dynamic sustainability experts and engineers, shared a dream of Vikalp, which is an alternate approach to design by moving away from the age-old practices. Their mantra of thinking out of the box paved way for creating Aeon integrated building design consultants. I'm sure that there is, if I have to introduce, it might take hours and hours to introduce sir, but without further delay, I would like to request sir to present his views. Over to you, sir.
Thank you, Nazim. Thank you so much. Namaskar, everyone. And if you can stop sharing, then I'll put my file there. Thank you. You need to, currently the screen sharing is disabled, Nazim.
Okay, sir. I'll
you need to enable that.
Yes. Sir, can you try now?
Yeah, thank you so much. You can see the screen now.
Yes, sir.
Thank you. So, namaskar once again. Good afternoon, friends. I hope all of you are keeping safe. These are tough times, and we have an emergency absolutely in many of the cities in India today. I'm grateful that Capricorn, along with Autodesk, organized this program on digital twinning, which is actually gaining a lot of traction. I started speaking on this subject a few years back, but the way like a tsunami has been coming into our industry, it's important that we all get exposed to this concept as early as possible. Suresh sir very aptly, as always, summed up the concept of the high performance building, the IGBC movement, and where does the digital twinning stands, and especially with the context of Forum of Critical Utility Service focus, which he has been championing for last over 6 months now. I'm happy that we have the context which is set in right. Since the time is short and we are running slightly over our scheduled time, I'll get into the subject right away. The intent is to show you some applications in the real world, what is happening in digital twinning. I'm sure as part of the green building movement, you have seen the glimpses of it, which have been done by the green consultants or the architects or electromechanical consultants who are trained in this area. But the concept of the integrated design still stays on paper. What is important is to look at the impact of the various processes or the options that are available on each other. And that's where we'll really be putting the digital twinning to a good use or to a right use and looking at an optimum design. If we have to move to a carbon neutral future, somebody I saw in the comment wrote that let's skip the net zero energy and move to carbon neutral. If we have to go leaps and bounds, digital twinning is one of the important aspects that we need to embrace. If you look at the concept of the digital twinning itself, it's been gaining momentum. Is basically a process in which a physical object, system, or design is recreated on a virtual interface. Now, it's been gaining a lot of momentum, as I said earlier, due to the evolution of simulation tools, better modeling capability, training amongst the users, and also the IoT coming into the picture. I'll speak more on the subject as we go later. If you see the last line where I've used the word models plus data is where the real value and the insights come into the building operation. I will also talk in the end where the shift is taking place in the industry. I'm going to just quickly walk you through the various examples of what digital twinning has been. I think we all understand the concept now with Suresh Saab talking about it, with me getting a little introduction to that, to see how it's been evolving. So I start with the fairly simple ones and then move on to a more integrated process which is there. I'm just putting an interface which was done a few years back with a master planner when we are looking at how to master plan the project correctly, with respect to the blocking, with respect to the massing, and also to use the physical features of the building to our advantage. This is where the psychrometric analysis is conducted to find out what strategy will work the best, whether it's the sun shading, whether it is the ventilation, whether it is evaporative cooling, what will work best for the particular climate. Each dot that you see on the screen on the psychrometric chart represents in 1 hour of the day, and together they give us an idea what strategy is working the best. For long, we have neglected wind as a resource. We've always been worried about sun. I think wind is another resource which is coming in fast. Now, these are the images that you've seen many times in past in terms of the shadow analysis which is done. Yes, it helps us to find out how the building massing is performing. Where are the shading areas? What time of the day the open areas get shaded? And how can the building mass be used to our advantage? It also comes down to using the wind. Now, what you see here is because of the dense population of the building, the wind flow in the open areas is not very conducive. The building blocks are blocking it. Now you'd be wondering, what is electromechanical consultant? I'm an MEP engineer, mechanical engineer. What am I doing about talking about this? This is where I want to bring you to an integrated concept that how does it impact our building design? We are all interlinked at the end of the day. Look at this, how along with the master plan, the master planner, the concept of reorienting the building blocks is being done, checking, testing how the new design is working. The evolution continues, and you can see the shape which is emerging. Improved building self-shades are coming into the picture, increasing more vegetation area, more green areas, allowing for the wind flow to happen, and see how the design has started evolving now. And this is where we ultimately come down to. You can see the area in between the open area has got a much better wind flow. By design, we created this wind tunnel effect at the ground level to give us a slightly higher velocity of air, of wind. And that's where you end up introducing evaporative cooling so that the whole of the internal area is being better evaporatively cooled and a thermal comfort is available to the occupants inside. So this is how at the master plan level, just give you a very broad concept of it. Again, sky is the limit. I'm just trying to get picking up on that. Where does it impact us as the electromechanical users? The better microclimate has an impact on the energy itself. We did save some of the computation showed that we have a reduction in the cooling load. We have a reduction in the energy consumption of the building. Whatever that number may be, big or small, please mind it is coming purely by design or reorientation of the buildings without spending even a iota or even a small amount of money there. It could be extended to townships. And what you see on the screen right here, a dense residential township where the building blocks, the way they have been done there is a self-shading street which has been created between the buildings where the pedestrian movement can take place. And then there is a road network where the vehicular movement can take place. The intent is, since this township is in a hot climate zone, the intent is to provide shading to the occupants or to the people who are walking there, so they're able to go from one place to another in a shaded environment. Using the wind studies, one can even look at currently orienting the buildings. You could see in this example, we have this open H-shaped building and a closed H-shaped building. What was discovered was this closed H is more aerodynamic in nature, allows the wind to pass through, whereas this open edge is capturing and not allowing the wind to go through to the adjacent areas. Even the spacing between the buildings, where the buildings are put, all of that can be better studied using that. And these are currently being done at this point of time. Some examples of the retail, I've just picked up a retail just out of the blue. It's nothing, no specific reason, even though the retail is not doing very well at this point of time. But this is where high street retail is being studied to look at the impact what the sun movement have on the facade. Now we all like to have a good, show windows given to the retail, which also impacts the operational energy of it. Now we have heard this many times. Those of us who are in the retail design arena, we have heard this, that the CAM charges or the operation charges in a retail world are the biggest killers, and that is why the box retails have had their challenges, and people are now moving to a concept of high street retails also. So this is how they are being studied here. Again, the intent is not to get into details of it, and you can find out where the critical areas of glazings are, what are the heat ingress sources, and how could you tackle them. This is a very interesting example where a high street retail has been planned, where only the shops are air conditioned. And what came out was that all of these corridors that you see in between in dark blue are supposed to be naturally ventilated. There is nothing there. Now, when we looked at the wind CFD models, it showed that there is practically no air movement happening in the common spaces, which are a key area for the retail. Now, this is bound to present a challenge to the users because it can become very humid, stuffy in case of monsoon, and in summers also it could be difficult. A simple strategy like creating those wind tunnels by moving the retail units from here to here or stacking them, look at the effect that it can create and what kind of improvement it does. Now, all of it is being done before you build the project, before you make the building, to get a better understanding of it, and then you get a much better utilization of the space also. Even using them for a skylight design. This is a project in which a skylight was there in the retail unit, and what came out was that skylight being unplanned or not being one did not have an insight into the design of it, was bringing a lot of heat, which was causing discomfort to the occupants, to the visitors. It was not allowing the show windows to have a proper display, and then adding to the operation cost also. Very interestingly, we see a lot of these tall buildings now today coming up, office buildings, commercial spaces. And this is an example of one of the commercial spaces which is there. And we generally like to box them with the glass because in a tall building it's easier to do, faster to do, and more trendy also. So here various types of glasses are being studied, glazing options are being studied to look at what kind of daylightings they're coming in. Obviously, the space is overly lit when we use lighter glasses, which is what is generally the preference of the designers. As we go up, that means we go to a higher floors, the problem becomes more and more acute. You can see all the red zones at the bottom. Most of the areas are overlit in there. Along with that also comes the challenges of the glare, which is uncontrolled and causes a lot of discomfort to the people. Things like we have heard about them, our National Building Code talks about it, ECBC talks about it, looking at an optimum window wall ratio in our climate. Obviously, it helps. You can see that it helps us to increase the daylight levels to a much better level. It also helps to cut down the glare, and you can add to it more innovative strategies like shading devices, which could be looked at, and you can even eliminate glare to a larger extent. On this project, typically the architect was very keen to have a clear glazing and double glazing, of course. And look at it, there were 93% daylit spaces are there. Moving on to it, there are more innovative ways also. There are parametric modeling systems that have started coming into the play. The innovative facade systems have come in. We use these shading devices, which are more architecturally appealing. And there are many architect friends that I know of, some of them in the audience also, who have been deploying them on their projects. Now, this parametric modeling helps to determine what is the optimum shading pattern could be, shades could be. There are over 1,000 iterations being tried, where there's a balance between the daylight, glare, and the energy consumption of the building. And here we are eliminating
we are getting a lot of messages from the participants that the PPT screen is very, very small.
Okay, so should I move it slower? Is that what you're looking for?
No, sir. Like your screen.
Okay.
Screen, yes.
I'll try to move it slowly in that case, if that's the case.
Okay, sir. So the window of the PPT is very small, which is appearing.
Small.
Yes, sir.
Okay. Let me come out and do that again.
Yes, sir.
Let me know if it works now.
Perfectly fine, sir.
Okay, thank you. So here we are. Once we tried that parametric modeling shading devices through using those, here it is 99% daylit and practically very little overlit space. On this project, we also looked at doing the basement, making that since there was only one basement, we looked at even getting the daylighting in there and making it naturally ventilated. So there are 4 critical cutouts which have been provided and which are around the building block. And they themselves, once you assess that, we found that it gets about 50% areas to be daylit, and to some extent, a natural ventilation is also happening. Using the tools, one can enhance it make it better. You can see here the more openings on the windward side, leeward side are strategically being planned. And as we did that, the basement is nearly 85% daylit. And look at it, the natural ventilation currents which are being formed. There's no need for mechanical ventilation to run in the daytime. So these are some of the examples you can look at. If we translate that, as I was saying earlier, if you translate it into a real life world of integrated design, here we are, a conventional design. If we had stuck to that without using the simulation tools, possibly we could have been at this building. We had about load of 1,800 tons of air conditioning, and look at the energy performance index, which is there. These step-by-step improvement help to bring the load down by by very significantly, and the energy consumption also significantly. And there is also an advantage to a client that there are, when you go to a restaurant, you have a menu card where you have a cost written there against each item. Similarly here, against each of the step, there is a capital cost, there is an operating cost can be put there to see which one suits the budget the best. And this project itself, we were able to save the chiller capacities, the transformer capacity, generator capacity. And I have been, incidentally, I've been vocal at many of the forums when people say the green costs more, or green costs 1% more, 2% more, or platinum costs more. I've been vocal to say, compared to what? If you look at a real good design, the green can cost significantly less, and platinum can also cost less to you. So the benchmarks is something that we've been struggling with. These are some of the examples of the existing buildings where the calibrated models, energy models could be developed. And here we are in one of the buildings, which has it's an NCR only, by the way, without naming it. And you can see here, the energy consumption of an actual building is right here. They have gas generators as well as electricity connection, which is there, the combination of that. That has been modeled against, a simulation model has been created. So basically a twin, a replica has been created using the computer simulation tools. And then various conservation measures have been studied. Some of them came from the architect, some of them came from the user, some of them came from the electromechanical designers. So a lot of those options are being studied, whether it's a building envelope, will an existing building unit make sense? Should I change everything to LED? Is it going to give me a right payback? Should I put a VFD on cooling towers? Should I put an insulation on the roof? What is exactly going to happen? I can evaluate it right there itself. So this is what has been tried out here, and various options are being studied. Moving it to I see some of my friends who are interior designers, and we tend to use lighting in our building. Now, lighting power densities, the LPDs have been under pressure from our codes, standards, and the green rating systems also. There are times when we used to design our lighting for 2 watt per square foot of energy. That means if you have 1,000 square feet of space, we used to use for lighting up to 2 kilowatts. I have done those designs myself 30 years back. Today, that concept has come down to 0.4, 0.5 watt per square foot. And our codes are saying it should not exceed 1 watt per square foot, 1.1 watt per square foot. So imagine what we used to do 2 kilowatts is now down to 400 watts or half a kilowatt only. With that, the quality of lighting, with that, the energy of the lights, that needs to be seen. These simulation tools can be very useful, like one of the cabins I'm showing here, where the kind of lighting patterns that are being formed, what is the average lux level that is coming out, what is the lighting power density which is being used, one can see there. So the placement of the fixtures is not the best out here, as you can see this. This is another cabin, and you can see what is appearing. There's a very bright spot at one of the locations, which can mean that we are using more energy than what is required, lux levels which could be higher. We used very successfully our simulation models for validating the indoor air quality at one of the projects, one of the hotel projects in Delhi, in NCR, where it proudly displays at the entrance, this is the kind of air quality we maintain inside the hotel. Now, that's very, one can say that just put filters and your job is done. It is not as simple as that. The simulation models told us a very different story. So you can see here there's a hotel guest floor, and on this guest floor, traditionally the fresh air is supplied inside each guest room, what we call a TFA or a treated fresh air. And in this case, the designer had done, there's an exhaust from the guest room toilet, and there's a certain amount of fresh air. The relationship between the fresh air and the exhaust was not adequate to take care of the wind pressure which was being exerted by the on the envelope of the building. As a result, the PM 2.5 particles, which is a critical element normally we study, were coming inside the room. That means since the inside pressure was not adequate, they were able to enter the room in case of higher wind pressures. And all the claims, all the solutions of putting the purifiers would not have been able to tackle this problem. A simple adjustment of the air pressure relationships using the simulation model told a very different story. And here we are, we were able to get a positive pressure inside the space. Whether it is in public areas, whether it is in guest rooms, the same thing can be used successfully. Even for validation of fire and life safety systems. Here we are in one of the buildings. What we are trying out is validating the placement of the extract fans, extract diffusers, and the capacity of the fan. How much time it takes for the smoke to build up, what is the kind of obscuration which is caused. That means when do I lose the visibility, and how much time the temperature rise takes place. So that validation is being done. And here we are looking at the visibility at 5 minutes, visibility at 10 minutes, what is happening and what is the temperature rise taking place. On the same project, very interestingly, the client said, why don't we look at removing the fan and opening the panels on the facade. Today, the National Building Code calls for that every 10 meter you should have an openable panel. So we looked at making those openable panels motorized and see what kind of does that perform better in this case. And that validations are being done using the simulation tool. So basically, it gives an insight into the design. And even going to an extent here, what you can see on the screen, how much time will it take for people to run out of the building? How much time do I have in terms of placement of the staircases, number of staircases, widths? One can do the validation of those using these tools. One of the things which I have not put here a case study for you is on an outdoor thermal comfort. This is a very interesting growing area. One of the temple projects that we are currently working on, without naming that again, in north of India, the requirement is that the devotees which come in, they get dropped off at the gate of the complex. From the gate up to the temple, the walk is about 1 kilometer. So you walk in 1 kilometer and come back 1 kilometer. Now, generally the devotees who are women, older people, children, would have a tough time in a northern Indian climate and here in our part of the world in terms of walking to that. When you have ambient temperature of 45 degrees, what do you do? Most part of the year, we have got a hot ambient. Even in September, when you have a direct sun coming in, it could be very uncomfortable. So the whole job was that we had to make that feel like temperature, as we say, not the absolute temperature, feel like temperature, bring it to a not exceeding 32 degrees centigrade using wind, shade, and water as a solution. Now, very interesting, the simulations were developed. I'm unable to show that to you because of the NDA, non-disclosure agreement, which has been signed there on the project, but I'm just bringing it out. That's the kind of work which is happening. The last one, you would say all of this is only a fad for the rich and the wealthy, or maybe the big corporate. I'm going to show you a small office, 10,000 square feet, using it. That's my own office where I operate from. The intent is not to boast about my office, but the intent to show you that even in a smaller office house, we can do the same thing. This is office which is 100% daylit, not even a single artificial light used in the daytime, not even in toilets and pantry. The office has got a green platinum rating from IGBC and also another platinum rating from IGBC on health and well-being scale, which is health and well-being rating system, which is now rapidly gaining momentum again. Simple things like looking at the ingress of the sun, placement of the workstations little away from the glazing so that there's no direct sun, no discomfort to the people. We maintain a temperature of 27 degrees inside the office, coupled with fans. So these are basically enhancing the air movement in the space. These are actual images of what is installed in the office. And believe me, we have been running at 27 degrees successfully without any complaints now for 3.5 years. When these COVID guidelines came, the first thing they talked about, enhanced indoor temperatures, enhanced relative humidity, better fresh air, and better cleaning of air inside. We have the air purifier units, which were installed long back, and also the fresh air unit, which is pumping the small quantity of fresh air inside. These are PM 2.5 levels that we maintain, 14 microgram per cubic meter, when your ambients are going up to 400, 300, 400, which are happening there. Simple things like evaluating what kind of air conditioners will work the best. And this is the image of how the placement of the equipment has been done. Even using the lights, using the simulation models, where the lights only come on the workstation, our LPD, the lighting power density, is down to 0.3 watt per square foot. The electricity bill for this air-conditioned office of a 10,000 square feet is yet to cross 70,000 rupees a month, which I like to believe that I'm getting a payback on my investment, whatever has been done there. The building featured in the ASHRAE High Performance Building magazine in US just few months back, where they talked about this affordably green. So bringing to the end of the subject, I'm going to exhaust my 30 minutes in the next 3 minutes. So keeping to the time, you've been hearing words like IoT, smart, which is what is all about metering, about feedback from the building. Couple that with BIM, building information modeling, or digital twinning, what we are talking about here. Use artificial intelligence, use virtual reality, which is now walking into our design world. All of that will take us to performance-based design. We are not far from the days when the RFP, which will come to you from a client, will only have one line saying there, my energy performance index of the building, we want it to be 50 kilowatt hour per square meter per year. Building will be net zero energy or net zero water or carbon neutral, whatever they want to say. That's it. That's your RFP. And believe me, my friends, you cannot achieve these performance until you have an insight into the building design, until you get into the integrated design process, which is where the world is pushing us. I just want to share in last few minutes one of the initiative which has been taken by ISHRE, which is the Indian Society of Air Conditioning Engineers, where IGBC is also participating, where we are looking at performance indexes that can define the operational performance of the building. Today, the only index that is available to us is EPI, Energy Performance Index, which talks about the energy consumption kilowatt hour per square meter per year. It doesn't tell us how the elevator is performing. It doesn't tell us how the HVAC is performing. It doesn't tell us how plumbing is performing, which is the most neglected industry today. It doesn't tell us how efficient our envelope is. It doesn't tell us anything except for an overall number. So we are actually working on this initiative of defining the indexes or coming out with indexes that define the performance of that subsystem. So you actually have now a benchmark available going forward where you can compare your building performance against the benchmarks which are there and see which of the subsystems is not optimally designed or not being optimally operated. Mind it, the future is not about design. The future is about design and operation. You cannot have a net zero energy or a carbon neutral building just on a design basis. Neither IGBC nor any rating system in the world will give you a rating on the basis of design. All of them give you a rating on the basis of operation, which is the next process after the design. And that's where all of the integrations will start taking place. Mark my words, we are not very far away from that. That's also coming like a tsunami. Thank you very much. I'll end there. You can always reach out to me on the email that you see at the bottom, and I'll hand it over exactly, I've taken my 30 minutes and I'll hand it over now back to the organizers. Thank you so much. Nazim, is over to you.
Thank you, sir. This is Abhishek this side. Nazim sir, can you just share your screen?
Sure, sure.
So thank you very much, Ashish sir. I loved how your projects incorporated both active and passive design measures for achieving thermal comfort, especially in your office space. So I think a lot of people have learned how to incorporate both these things in the small spaces as well as larger spaces. Also, I would like to highlight that now we'll take some questions before we continue with the next speaker.
Abhishek, I suggest that we finish with
Yes,
the
sir.
speakers because the time is running out. So
Right.
we can come back to
Sure,
because we
sir.
have wonderful presentations coming from Sachin and Nazim also. So
Sure,
I
sir.
would
Sure.
finish those.
That will be great, sir. Okay. Yeah, if you can change the slide, Nazim sir. So over to you, Nazim sir. I think for the poll.
Okay. So we'll just run a quick poll again. It's just going to take a few seconds. This poll is related to, because we have got a lot of questions related to this also. So anyway, I'll just share the
So
poll.
before this, we have a lot of architects also. Can you just explain a bit about CFD?
Well, for me, it's so let's ask audience if they are aware about what the CFD means. First of all, let's give audience this opportunity.
Sure, sir.
So this is the poll in front of you. So I would like a lot of people to participate. I see a lot of people already participating. 20 already exceeded 35%. 50% of people have already voted. There's a spike, huge increase in the participants. I would like all of you, if it is possible, I would request all of you to participate. We'll take 3 more count, and on that we'll close the poll. Okay, fine. So let's end the poll here. So we have got a good ratio. By the way, like we have got a good ratio. If you can, I will share it on the screen. Also, we've got 75% of the people who have participated that they are not aware about CFD, and 25% of the people who participants, they have said that they are aware about the CFD. So I would like to, let's ask. So Abhishek, over to you. I mean, you can take it forward from here.
All right. So I'm going to introduce the next speaker now. So Mr. Sachin Fulsundar. Sachin sir is a technical solution manager specialized in Autodesk simulation portfolio. He has done masters in plastic engineering from UDCT and has spent time within product development, processing, and mold design industry before moving to the world of simulation and CAD. At Autodesk, Sachin has worked with various manufacturing solutions, including Fusion 360, and has been involved with Autodesk's mold flow PDTs for over 20 years. So over to you, Sachin sir, for your presentation.
Thank you, Abhishek, for that kind introduction. And probably as the one who is the least experienced among the speakers, Suresh sir and Ashish has, I would say, a tons of experience, and their slides as well as their talk, clearly reflects that. So I've been given like in 20 minutes to talk about it, and I'll try to, something or overlap the what the Ashish just mentioned on that, but I will not cannibalize what Ashish has showed it, but I will try to give some more value to what Ashish is trying to say. I'll start with the very basic. Let me share my screen. Let me know once it pops up.
It's visible, sir.
Okay, thank you. Great. Okay, I'll stick to my timeline of 20 minutes and so, but we will get started with the very basic part of it. I know some of the members on this session are completely new to the computational fluid dynamics. So what today I'm going to talk about it, how to use Autodesk CFD for those design validation and optimizations. Everybody on the call would be a designer, engineer, architect, MEP engineer, and some of the other way been contributing to the our AC industry. With that, I want to get started with then a basics of what Autodesk CFD is all about, or in the basics, what CFD is all about. I could see that some of the questions coming in the text and Q&A. Hey, we want to know on the CFD part of it. And I thought of putting this slide is like CFG stands for a computational fluid dynamics. And what we do in the CFD is like a modeling of the fluid flow as it interact with the surroundings. Ashish showed a lot of examples on the surrounding interactions as well as the interactions with the inside the building with the MEP equipments and so. So in and all, we are going to tight shell your building or surrounding with the fluid, and in this case, our fluid will be air. Or if you're working on to the smoke, still it's like gases, and of course, if you're working on hydro projects, it could be water. And when we are trying to do all the simulation of air calculations, air circulations, we try to map that with the heat load, starting with the source of heat and how it differentiate along in the room, around the building, or whatever the things that you want to simulate at the equipment level or at system level, we can map that. I think that is I think the shortest definition that I can give it to the technology. I know it's not justifiable for that. Again, it's very vast, and CFD finds applications very vast. AC is one of the area, but you will find the applications into the mechanical and electronics industry as well. Now the basic question arises: why we need to do and see simulations? To start, let's remind ourselves that there are need for the customers to perform a building analysis or simulations. Why need it? To validate this building design. You are designing something, but how sure are you that it's going to perform in the way we want to it when it is put into the actual real world scenarios? Well, I'm not saying that we are not been doing it till today or tomorrow we'll not able to do without the computational fluid dynamics. But like Suresh sir mentioned, that we really need to increase our pace of development. And when we are going to increase our pace of development, there should be a little chances of reiterating the work that we have been doing it. Well, we've been doing phenomenal job till date using hand calculations. But some of the times we also have to accept that these hand calculations becomes impractical, or there is a chances of getting wrong with that. And the other alternative that I find it is using a scaled model. But look at that, how to the bigger extent we can scale the model. Some of the models of the like township modeling cannot be scaled up. I mean to say it requires a lot of I would say time as well as the efforts and money to be put to be exactly replicate the same things. And I know that many of the engineers on this call, they are very passionate about that design, and they want to really take the deep insight about the design performance. So that probably the one of the reason I find we need a simulation over here. But if you want to do a simulation in the real world scenarios, you need to
Sachin, it seems we have lost your connection. Nazim, you can Just check.
I will connect with him, sir. Let me just connect with him and check.
I think he's just logged off and logging in again.
Okay, sir.
Yes, Sachin, please continue.
I think I lost her here for a minute. I'm very
Yes,
sorry for that. Okay.
you can share your screen.
Okay. Okay. Are you able to see my screen now?
Yes, yes.
Okay. Thank you. 1 minute. Sorry. Just between fumbling between. Okay. And then there is also a need for an sustainable or energy reduce or optimized design that we are going to deliver it. At the same time, we have a pressure from the government regulations to have a much energy efficient buildings to minimize our resources or optimize our resources. And Ashish showed some of the examples of his own office, that how he has been optimizing those resources, and he has used simulations to extend to optimize those things. Of course, these are the few of the reasons that can be one of the simulator or need for to have a simulation for your design. When we are talking about the CFD, it is important to emphasize that CFD is not a silo solutions. Please don't consider that once I learned this one, I could be sitting in the corner and doing. In the area of the connections, as a traditional silo disappears, I will think that BIM will provide the foundation for the success, and thus enabling us for the entire life cycle from design, build, and operations to be seamlessly connected. As you see on a screen that we have more than 10 well-established Autodesk products, and probably Nazim and Abhishek would be the experts on this to know about those products, how they can be integrated well with the CFD on this. One thing again to emphasize is that with the CFD, you can connect to the multiple tools within the Autodesk systems, like it could be from design updates coming directly from the Revit, or visualizing the results with our visualization solutions rather than just putting into the color plot. How you can make it more visually appealing to your clients, so that they understand that how the design is performing into the real world scenarios. Or it could be sharing the data to your clients sitting all across all together in different continent, rather than sending it over the mail, but getting a feel of interactive data exchange between this. So CFD is one of the tool of your BIM, connected BIM, I would say. Let's talk about the key application area. Both the earlier speakers has talked a lot about it into the key application area. So I probably want to a little bit differentiate my presentations. As I told you that I'll not, overshadow what Ashish has mentioned, but I will try to enhance his message into the working into the key application areas. So this particularly a single slide that try to, I would say, concise the application areas for the CFD, starting with and understanding the ventilations within your room, or it could be operation theaters, or expanding all the way to the even airports to understanding that the humidity level, the comfortness of the passengers, and so, or it could be used into the hydro projects as well, or into the town planning altogether, understanding the airflow movement and how you are going to place the buildings across each other so that there is enough ventilations and not making any swirl noise as the wind rushes through the gaps and passages between the buildings. Or it could be used for even the designing of the bigger infra projects or like in the designing of your bridges and so on and so forth, or could be in understanding the factory audits. If the fire breaks out or the something contamination breaks out in the factory, how it is going to affect into the neighboring or surrounding area. And often, if you are not following the factory standards also, you will be also be charged or penalized for the pollutions or contaminations that you've been living into the environment. Or going back to the retrofitting it. So I have actually a server house. Now I want to make it more efficient or energy efficient. How can I make the ventilation better and save something on my HVAC systems? So retrofitting is one of the areas where the designs are making little legacy older and they want to make it more efficient, where CFD can be find it very useful to create an as it is scenario, or I'll call as in twin digital, that replicating the existing design into the computational form or digital form and look at that how it is performing, and then you make the changes to it. We'll touch upon a few of these applications into the forthcoming slides. With that, I want to start upon onto the air quality index, setting the to make sure that we have an improved air quality index, or also referred as a IAQ. Ensure that all the occupants in the room have the enough, I would say, air exchanges in that given period of time, and there is no stale air or volatile content or a CO2 or other naturally occurring pollutants in that area. So, and also the CFD also help you or MEP engineers to represent all the equipments in a much simplistic form, so that they could look at that how these equipments are impacting the air movement within that room. Now I'm showing the one of the example of an exhibit room, and you can see that how visually appealing it is. That really I didn't need that understanding or expertise of result interpretation, but I computed it and put it in a very simplified form, and probably this could be the best way to represent your findings to your customers and help you win more wins or bids for your business. Now this can be further taken to the much broader areas, like in factory audits, understanding the air circulations within the factory, so there is no contamination of the air or stale air within that factory premises as well. And same as it can be further be taken to the external or wind tunnel calculations also can be done using a CFD. So we'll look onto the details into the forthcoming slides as well. Now, common problem solved using the delivering the air quality. I think Suresh sir, Ashish did touch upon some of the industry codes that are related to the air exchange per hours or the thermal comforts, and then volatile material concentrations or tracking emissions, or even safety related things. In the forthcoming slides, I will focus a bit onto the air exchange per hours, and then touch upon the thermal comforts, then volatile material concentrations, and also on the safety of the buildings. So with that, I want to get started with the how CFD can be useful into the air exchange per hour as per the industry standard ASHRAE. I want to take an example. What could be that? So this is in situations where there's been crisis for the oxygen in the country. There have been crisis for the multiple resources could be related to the health. And I find that this was a time that I can share some of the topics or how the people or how the industry been using CFD for the during the COVID. So just to give a background, like what is the difference between the droplet and airborne transmission? Droplet is something that when we cough, when we sneeze, can be spread a droplet of saliva and the mucus, something. And airborne transmission is like the tiny particles possibly produced by the talking and suspended in the air and for a longer time, and travel further. So these are some of the areas that really is impacting every one of us, if you are not taking the proper care during this pandemic. And one of the area which everybody talk about is that keep your thing ventilated. Okay, I think natural ventilation is one of the area that everybody is stressing of, that let the air come, let the fresh air come, and so that the contamination is gone. But if you want to have a recirculation of that, then there probably you are increasing the chances of infection over there. Well, in the how then it is been dealt into the hospitals? Are they like they are working on to the like in ventilation or natural ventilations? Probably they are using a very high quality type of filters or HEPA filters. And one of the things that everybody is trying to use or everybody is getting repeated message is to wear a mask, is something that we are trying to avoid that spread of the droplet or transmission. And at the same times, when we are breathing, we are having a filtered in front of us to avoid the contaminations by the tiny particles which are already present in the air. So how does the safe defines the application in this area? Before I go and show on the some of the examples how people have used the CFD during the COVID situation and improve on that design, this is something recommendations that I like to put from the as per the air industry standards of like we should have like a minimum 4 air changes per hour. Then more the air changes per hour, it's much better to have that one. No recirculation of the air unless there is a filter in place, and could be HEPA or UV, or more effective if the outdoor air is introduced. And possible mitigation strategies are like opening the windows, adding the box fans or the open windows and dedicated exhaust fans, portable air filters, and so on and so forth. So these were the few of the measures which we can take during these COVID situations to avoid the contamination or spread of disease. And this is the example which one of our customer has shared with us. They are the pioneer in the manufacturing of the HEPA filter. So AAF is the name of the company, and they've been manufacturing the filters for the various industries, including the medical. So how they use CFD to investigate the influence of ventilation and filtration system on the infectious diseases transmitted by human cough, generated aerosols in different spaces using the Autodesk CFD. The goal was to find out how ventilation design, or let me show you the animation part of it. So goal was to find out how ventilating ventilating design, air purifier, and filter influence the risk of the infectious disease transmission in different ventilated spaces. Probably this is where you can see in the animations that if a person coughs or sneezes, and probably it is contaminating the neighboring area, along with that, and same way it gets absorbed into the filter rather than creating the infection to the neighboring person over there. So these are the some of the studies which probably cannot be done using the live dummies or something, and this has to be delivered much at the faster rates, looking at the way the infections is going. So to minimize the infection risk, they are been still validating the design, and probably they are using the CFD to understand that how the propagations or the droplet movement is happening in this in the air. That was one of the example, but you can see that these can be further be broadened. This is a little longer video file. It can be taken into the like a transit stations, subways, airport, or medical operating rooms, or waiting rooms, or even can be further looked onto the office buildings as well. So one of the example is that into the like if you're sitting in a waiting area, and probably if the person sneezes, it is possibility that it is going to infect to the person sitting next to you, or in the person sitting right in front of you. So having a protective shield is most important in this type of scenarios. Or take a scenario, if you have a group of doctors working on to the operating table, and then something, if contamination comes from the one of the doctor or one of the members, and probably he would be infecting or contaminating to the whole of the areas. So all these as if scenarios can be very much be simulated. Now sooner or later, we will start our office. I'm wishing so. I've been working from home for quite more than a year now, and eventually everybody will go back to the office. And probably if to avoid the contamination, what should be our space area? How should we be physically distancing each other? If somebody sneezes out of it, will it be contaminating to our colleagues? And so all these type of detailed studies, where it may take a little longer to do using a physical prototype, can be easily virtually simulated using the CFD tool. Now I'm really running fast over here to save some time. And now the other application that I want to talk about, which Ashish also touch upon, is the occupant comfort. So this is an example of an office lobby. Probably when we are in this tropical country, when we go into the office lobby or some there, suddenly we start feeling a little chilled because the AC is running to the fullest, and person sitting some right below the thrust area may be feeling very cold actually. So CFD has a results which are directly related to the industry standards, some of related to the comfort of the human. So we have a result called as a predicted mean value, which gives an understanding how the person is feeling when he is sitting in the reception area, or he is sitting into the office area. He should not feel too cold. He should not feel too warm as well. So understanding the temperature or the comfort of the human is one of the part of the study, or what we do in the CFD. So in CFD we can calibrate the dummies or the calibrate the human as if he is wearing the clothing to that detail. You can give inputs to the code. The other area is onto the safety aspect of it, understanding the smoke mitigations, particularly engineers, MEP engineers, as well as the architecture engineers who are working. They want to understand that if there's fire breaks up, what would be the least, the path that it will follow. So CFD help you to understand that what type of material can be burned, or to understand that if you're burning a specific material, what would be the density of that smoke, and how long it will take to reach to that specific area. Ashish showed that one of the example of how much time it should require to evacuate the building if the smokes break up. But it is not only that, but we can also understand the density of the of the smoke, and can I be able to get the visibility of that exit sign. So, and this is the one example of a car parking where in nowadays we put lot of makeup units so that the fresh air is continuously being pumped into the buildings. If at all there's some fire breaks up, then it can be pushed. So we are putting these buildings actually into the positive pressure, something if something breaks up, it should spread out very easily to the ventilation system. And to the understanding the the external airflow. So you can take your completely BIM model or your, I would say, I didn't come up with that terminology, but you can take your complete design of the town layout also into the CFD, and you can see that it is much into the simplified form where you understand the characteristics of the the flow that is happening within the building. Now this can give you understanding that where is the low pressure zones around the buildings, how much is the pressure that is getting developed onto the walls of the building, and it can be further be used for the sunlight or the solar study as well. So solar study particularly will help us to know that which area of the building is been continuously exposed to the light and how much energy is being absorbed that wall. And particularly you can save upon your energy, that amount of energy that is needed to cool the building or maintain at like 27 degree centigrade. So very detailed solar energy study throughout the day as well as throughout the year can be carried out using the CFD solutions. Probably the couple of slides more, it can be useful for understanding the factory audits, like the contaminations or the emissions that is going out of the factory, and how it is contaminating the neighboring factories as well as the environment can be very much be simulated. But it has the applications into the bigger as well, into the infrastructure industry as well. People been using it. This is the example of the bullet train where CFD is being used to understand the wave propagations as the train passes through the tunnel and how much of the pressure being generated into the tunnel. At the same times, how the wave gets propagated as soon as the train enters into the tunnel. Now it can be used to understand the air systems or air circulations for the train cabinets. It can be further be taken to the hydro projects as the wall gate or the gates of the dam opens, the water rushes, and then how much would be the pressure getting exerted onto the walls or the boundaries of the dam. This where we are talking about the bigger part of the of the systems, but I know that during this on these sessions we have the MEP engineers as well. So study can be done onto the MEP equipments which been used as an accessory or the fitments to the your building structures. So understanding onto the simplest study over here is understanding the what should be your lure design. People been using the CFD to even to design of lowers so that we have a maximum air coming inside the room. So with that, I would say I've been just a little over time, but Autodesk key CFD benefit is that it doesn't really need a specialist to run the simulation or use the solutions. It's fully integrated with the Revit. If you have like a Revit model, then probably with one click, you can push in the model from the Revit to the CFD. Most of the things are being automated. The materials is been directly taken from the Revit. So you save time in, to the assignment of the event. It has a real life type of visualizations as you see into the actual reality. The things that you see on your screen, these are being rendered within our CFD solutions. So with that, I think I will pass it on to Nazim and Abhishek, and I think we can take the Q&A latter part of the sessions because Nazim has his role or his presentation to be done as well. Over to you, Nazim.
Thank you, sir. It was a wonderful presentation. A lot of 75 people, 75% of participants, they had no idea about CFD. I'm sure that this presentation from your side has given them a lot of knowledge on CFD. Now I think they can proceed with, if they were planning to do something related to CFD, and even if they have some queries, we'll take their questions. We have a lot of questions from the participant side. So thank you so much, sir. It was really great. For me also, it was very learning. So Abhishek,
Yes, thank you, Sachin sir. It was really informative for me also as an architect. So now I think I'll not waste much time and I'll just introduce Mr. Nazim Khan, who is the co-host with me right now, and he's going to present BIM and Revit for energy analysis. Over to you, Nazim sir.
Thank you, Abhishek. So we have already run out of time. I'll not take a lot of time, probably a few slides, and I'll show a quick demo. So I am going to talk in terms of BIM and Revit for energy analysis and system analysis. So we have Revit has developed a lot with along with other softwares like Audits Insight and Audits CFD. We have already seen a lot of things from Audits CFD. So quickly, I will I'll take another slide where we discuss why do we need to, how Revit helps us in energy analysis. Revit, it helps us in doing the energy analysis at any stage of time, be it a conceptual stage or be it a detailed stage, because we understand there are a lot of advantages of running the energy analysis at the conceptual stage. The early we run the energy analysis, the better results and better performance we can compare. So there are many benefits, including integrated analysis and modeling. You may compare performance of alternate design strategies. Early stage design decision have great impact on building performance. And looking at a lot of so we can run building orientation. We can see window wall area per, ratio. We can see the building form, lighting part, densities, and other things. So heat load, first I'll start with how we are able to do heat load calculation in Revit. It's important to understand why, because it has great impact. It takes high percentage of energy consumption in most of the commercial building, has already been, from the expert we've heard that. So I'll not spend a lot of time in going through it. I'll just jump on to Revit. So you can see this is the Revit application that you can see. And here we have this entire panel in Revit. I'll show you the Revit software at the same time. So we have analyze tab, and that we can define various spaces. So spaces have different rules. So in Revit, we have entire tab dedicated for analysis. If you have created the model, because Revit is also a design authoring model. So the work starts with an architect. He develops a conceptual model or a detailed model, and that can be taken directly for energy analysis. We can create various spaces. We can create various zones, and then I'll take it to further. We can define various, these are the spaces that are there, and I am combining various spaces to make a zone, because these four spaces, they have the same condition. So they together have created one zone, and we can edit the zone. What all do we need in a zone? We can give the name of the zone. We can give the numbering of the zone name and other things, and we can decide what kind of system are we going to use for it. So further moving on to this is the tab we have for heat load calculation. I missed that. So here we have a tab tool called heating and load calculation, where we are going to see the 3D model at the same time. And plus we can see other things like what is the building type, what is the location of the building. All those can be set. And there are both types of location availability of internet system also, and meteorological data is also available in Revit. With all the driver temperature throughout the year, we have all those things. I'm going to show you that very quickly. So this is a space. We are going to define various condition, building infiltration type, and building envelope, what kind of building envelope we are using, and what kind of report we need. So quickly, I'll take you to another step. So we can change all these. These are all customizable. And at the end, we understand that one of the most important thing we have already heard from the expert is that the envelope of the building and what are the material you are using. That also plays a very important role. So just to show you that here, that in Revit, we have an option where, you can define the various factors. So if you are using roof, what kind of material you're using for the roof, and you can set the U value for the roof. You can set the U value for the exterior wall, interior wall, ceiling wall, and floor slabs, doors, exterior windows, interior windows, and these are the external envelope that we are seeing, and these are the U factor related to it. And of course, we need to also look at the internal loads that we are going to see. I'll show you that. So here we can, you have analytical surface. You can see that within a zone you have 4 spaces that we defined earlier, and we can see it visualize here. So we are seeing it individually one by one, and then we can also see individual elements like where is the wall, and what all. So individually we can see this zone, and further to that we can see, you have roof. This is the roof that we have. Air gaps are mentioned. These are only for visualization and checking. We can check it if we are going right or not, and these are different color coded, so that we can see, okay, these are exterior walls by green color, and within the exterior wall that is on the south, and we have windows. So we have that, everything is mentioned very clearly, and this is the space type that I was talking about. So we understand that ASHRAE gives us a lot of values of various spaces. Like with internal loads, we have lighting load density, power load density, what is the area per person, what is the sensible heat per person. So all those data are fed here within each space. The scheduling, everything is fed already here, and we can customize these values. These are all customizable. These are something that we can customize, and it's going to vary from dining area to office to other specifications. So this is the kind of report that we get. The zone summary, these are total heat load calculation that we've done, and we've got like this much of heat in British thermal unit per hour we've got, and all the unit can be interchanged. I mean, if you want it in tonnage, if you want it in kilowatt, we can change all of those values, and we can work on that. And the report that we get is very detailed. You have as per zones also, as per spaces also, these are defined separately. We can see percentage wise also that how much percentage of heat we are getting from which zone, which area, which wall. We can see all those specifications. I mean, it's very detailed. Okay, moving on to the next thing, solar analysis we can do in Revit. It's very easy to do. We can get a result like this schema, and immediately I'm going to show you. So we have in Revit, we have a solar analysis tool. You can run the solar analysis tool, and you can feed various information. I'm going to show you that also quickly. So you can feed various information. You need annual custom result, or you need solar analysis on only the roof exterior surface or all mass faces, or you want to select where all you want. So you can select it as per your requirement. So let's suppose I select the roof area, some of the walls that I want to take. Okay, and some of the various walls that I want to take, some of the facade, all the facade that we want to take, glazings and curtain walls, everything. And now I will only take these areas, and Revit is going to tell me how much area I have selected. I don't have to, find out what is the area, because I've already modeled it into Revit. I've already provided all these informations to Revit. So quickly, you can provide solar settings in the software. Like if you can do, so this is sun setting that we have. You can see, you can give it for summer solstice. You can give it for spring solstice. You can create it for a single day. You can run it for multi-day. You can, define the timings and other things. And I'll just quickly take it because we are already, we have seen all these things. I'm just showing you how you can do it actually on an application. So we have to feed this information. You can see that the result that you want in kilowatt hour per meter square or British thermal unit per square feet, all these things can be fed. These are all customizable. And finally, you're going to get a value like this. Okay, these are also customizable. You can, the grading, the color coding, all these things you can customize, and you can get a result like this. So this is in Revit that you can do. So we have seen how you can do it, solar analysis, and quickly, one of the last few slides, daylight analysis also we can do. You have the sun setting we have already provided. If I want to see, like we have already heard it from the experts that we need to, let's see, as per our design on the architecture building, how much amount of daylight we're getting from the outside, so that we can decide how much artificial lighting in terms of lux we are going to take, we're going to use. So that is something very important that becomes important. How we're going to do it on the software, that is a question that we need to look at. So the same model that we have lighting analysis also here, and we can see you have you can run a new analysis. There are various factors on which you can run the analysis. On the lead illuminance analysis, you can do daylight autonomy, you can do as per lead B4. So you can take the value, you can define the daytime, other things, threshold you can define, axis plane height you can define, and then you have you can run it after that. So there are various settings. Apart from that, what is the sky model that you have? We can take the setting as per that. You can define these settings as per the requirement, as per the client, as per the project. You can do these changes. So here it goes. So we are running it, and immediately we'll get it. In just few seconds, we are going to get a result. So so we get the result like this. We can have multiple results also at the same time. So it is going to show us that this is the amount of lux we're getting. I missed it. Yeah. So this is the amount of lux we are getting. Orange depicts so the orange depicts highest lux level that we are receiving here, and then we have yellow, and then we have it keeps on decreasing. So from 0 to 6,000 lux we are getting, and we can see it in the model also, that we have orange patches here, we have yellow patches here, and then we have other patches there, other side. I think yeah, just cancel it. Yeah, so lighting, daylight analysis we have seen. This is the Revit in front of you. This is the screen that we have. We have this model, and we can see other things also. I'll just show you one small result. Apart from that, we need to look at one more thing. Like a lot of people, they had their queries that in heat load calculation, a lot of times we are not able to see the psychometry. Now Revit gives you that result also. You can see various results in terms of psychometry also. You get the result in terms of zone load summary, system load summary, and design psychometry. So you can use building element, room spaces as per requirement, and you're going to get these peak load, cooling load, all those things you're going to get, and you can verify it as per the equipment also. So as per the equipment, you can verify various results that you're getting out of overall result. So that is very, very useful. That has been developed into the application, and we can also see individually the cooling. Where are we getting the cooling from? Where on roof, other glass, ceiling, conduction, and we can see the psychometry result also. So that has been a very good development into this, and with that, like I just yes. So yeah, so we have covered most of the things here. I only left with energy analysis setting and how we can push it on the cloud. So I'll just share the results. So this is in Revit, if you can see, we have analyze, and in here we have something called as energy settings. And in energy setting, you can, even if you're with the conceptual model mass, you can do the energy analysis. You can provide various values to it, and depending on that, what is the export complexity, you can give with the shading surface, other things you can define, and you can define other things, building type, building operating schedule, all these things you can define, and finally you can push it on the cloud. There's something called as energy optimization, and we generate it. When we generate it, it takes your model to the cloud, and to the cloud on Insight, Autodesk Insight. So let us look at the result. This is Audits Insight. This is a model that has been already uploaded, and we can compare it with the Architecture 2030 standard and ASH 90.1. This is the plus operating cost. Like this is good mark. It is green. Otherwise, it would have been red. The color code is also very important to understand here. So we have a very good operating cost to the building. And how are we getting that? By these factors. So we have building orientation. So this is the current building orientation we have. And if we look at this, we are getting around 6.84 USD per meter square per year. This is the energy cost mean that we are getting. And if you look at other things, what is the window wall ratio that we have kept? What is the shade that we are using? What is the glass? What kind of glass we have used? All those things we can see, and it is going to suggest us based on that. If you use, for example, here you can see other surfaces also. So if you're using uninsulated, for example, it is going to increase your cost of the building. So if you're using R2 as an insulation, if you're using other materials as a wall material, you can get better optimization. So you can show it, you can work it out, you can see what is the best optimized result, what kind of material if I use it is going to optimize my design. So you can look at various factors like roof construction, infiltration, lighting efficiency, depending on, like, for example, if you look at this, we have used somewhere around less than 7.53 watt per meter square. But if you use lighting load of 20.45 watt per meter square, it's going to take a peak. The energy cost is going to take a peak. So these things, you can come back to it. We can see that, okay, this looks better. This is what I should use. So this is Audits inside, and we can, compare various results. If we, look at, I'll just show you the home page, and that's the last site from my side. So yeah, this is the homepage of Autodesk inside. We have, once the loading is over, you can see various projects that are being displayed here, and we can compare. In the last project, we were able to, get better result in terms of energy savings. Are we getting better results or not? We can, see the results, minus 2025. So here we can compare it also. We can see the scenario. We can compare it on the net zero sample also. You can compare it on the architecture 2030 scenario also. So we can, compare it on various scales, and you can see that, okay, these are, the results. So here you can see the maximum, the minimum, the scenario as per if the sample includes that. Plus you can, see, you can set the unit in terms of metric imperial, you can set the annual cost, EUI you can set, and you can set the utility rates also. So this is very good in terms of application when you want to optimize your design, and Autodesk Insight in combination of Revit and Autodesk CFD, it becomes a very good combination. Thank you from my side. That's all from my side. So I think we will take questions. We'll ask Abhishek to take some questions.
Thank you, Nazim sir. So I'll just read out a few questions, and then I think I can put them to Mr. Sachin, I think, because Mr. Ashish has left. So we'll be taking those questions, and for Mr. Ashish, we'll be taking those questions and emailing you the answers. Whoever wants to ask any questions, you can email at connect@capricorn.com. But still, to Mr. Sachin, I would like to ask this question. It was put by. Yes, just 1 minute. Yeah, it is put by Mr. Sivaram. It's a great session, sir, he says. I would like to know how you can differentiate between BIM and digital twin. This is what he has to say. So your thoughts on that, sir?
Right. So basically, I did mention about one of the lines during my presentation that BIM is the foundation for your design and overall product life cycle when it comes to the AEC. So basically, BIM is where we are digitally creating your model or replicating what you're going to design it, or what Nazim was trying to show it is a part of the BIM. Now, once the BIM is done, then you put that model onto the, into the CFD for the for getting the environmental or real-time environment outside the building or within the building. So replicating the actual model digitally is called as a, is called as a twin digital, or what do you call it? representation of the model in a digital form. And then whatever the permutation and combinations you want to work into the design, changing or moving of your MEP equipment or reiterating on your HVAC system can be further be done in your digital model. I hope that answers your question. So basically, it's like a digital representation. So BIM is used to digitally represent the model, and then CFD is used to validate that digital model.
Thank you, sir. Nazim, do you want to ask any questions to sir first, and then we can get along with this?
Yes, we have a lot of questions, but I think you can, introduce. I think if you can see the screen, I mean, it would be better that if we can also introduce at the same time regarding that.
Yes, sir. Sure. So Capricorn is running a few programs for BIM for Design and Revit MEP. So this particular program, BIM for Design, is focused on design workflow and project delivery using BIM tools. And it will encompass about 120 plus hours of training. And it will deal with tools like Revit, Navisworks, BIM 360, Dynamo, Format Insights, BIM standards, etc. For any kind of training inquiry, you can email us at connect@capricorn.com.
Also, I think.
Also, there is a Revit MEP course which is going on, and in this Revit MEP course, we are going to teach you one-stop solution for design, modeling, fabrication, and collaboration of various building services, and that will be mainly done through Revit, Navisworks, and BIM 360 and Dynamo will also be covered in this course. And then we have one more program, that is Capricorn BIM Guru. Capricorn BIM Guru is basically the corporate package wherein we'll focus on BIM implementation for design consultants. It will be a 1-year service contract only for architects, and 40 hours of tool training, 50 hours of online troubleshooting, and 1000 plus Revit content for fast delivery. That content is basically the libraries, the families. So again, you can email us at connect@capricorn.com.
Thank you. Thank you, Abhishek. So I think we can take more questions now. We have a lot of questions. One of the questions that is there from one of our participants is that this is to Sachin sir again, sir. I mean, I would like you to answer this. This is very important. I have heard from Mr. Arunal, I've heard from many people that energy simulation results very highly from actual results. So how can we validate model of new building or verify the result of simulation carried out with actual building? So, we would like to understand from you, are they actually varying the simulation that we do on the software, and which is actually, if we do it physically, will it vary a lot?
So let me put it in this way. When we try to represent the actual scenario, let's not complicate the model with a lot of things in place. Like the model which Nazim showed us was having a lot of details in it. But if you refer to the Ashish slide or few of my slides, when we were doing a calculations, we were taking a very simplistic model. So try to build upon your model as the complexity goes on rather than reducing the complexity to a sense. I always believe in starting with a simplistic model and then solving it and looking at the results and eventually building the complexity to the model. And once you work with this process, then you can take your complicated model. Now, coming to your questions, why there would be a chances of varying between a simulation result and to the actual one. Basically, simulator, any of the code that you take available in the market, it needs the input. If you're going wrong with the input assumptions, then probably you expect the same thing will come out from the simulation. Yes, to some extent, we have to make the assumption, but the assumption should be in that calculated error. So two things is how well you're representing the model to the simulator or to the solver. It should exactly the same replica. And second is that what are the parameters you are putting into the software? I understand there could be a little assumption set, but the assumptions should be in that stipulated. If you take care of these things, I think there is no way that you can see a big difference between a simulation and the actual.
So I like to add to what Sachin has just said, and very important is what we need to look at the purpose. So what we have shown you just now is that you can actually run simulation at various stages of design. Now, if you're running a simulation at a very early stage of design, then you want a very rough estimate of your values at that stage. So you don't worry so much about that. So it's also all about how much of effort you're putting it and what kind of results are you expecting. So at that stage, of course, your model is very simple and you don't want to put too much of effort to run this thing. So what we're trying to show, and as an Autodesk, one very important thing is how easily you are able to do all these things. So what Autodesk is trying to do is make all these things available to you very easily, that you don't have to spend too much money either in the software or to specialized people to be able to do that. And that's where you need to look at. Now, if you want accurate result, you need best of the software and best of the people, like what Sachin just mentioned, that what assumptions are you making. Now, those assumptions can be only given by specialists. But as a general user, you don't know all those things, but you will still get some good results, which will help you in improving your design. So we need to look at those purpose also and think through in those directions also.
Thank you, sir, for adding those comments. Very valuable.
Sir, there is one more question I would like you to take to Chikresh, sir. This is because you have been into this for a very long time. So one of the participants have asked how difficult it is for an architect to do energy analysis. It's one of the questions that we have received. They have said it easy, but I've turned it into difficult.
Okay, and of course today we were trying to squeeze too many things within the short span, and so what we heard from Mr. V. Suresh, that how you need to think at a policy level, and how then we saw some good applications from Mr. Ashish, but then we also tried to run in the software, and where we have shown some very simple software like Insight. Now that software like Insight is something which is actually meant for all the architects. So you do quick early design in Revit and just push it into Insight and then study various permutation and combination and improve your design, which any architect would be able to run through. So it's today, that's exactly what I just mentioned, that Autodesk entire focus is to make all these things available at a good affordable price and make it so simple that most of the people are able to use it. That's where the entire Autodesk tries to sum up their entire technology focus in one single word, which is democratization of technologies. And that's what they excel at.
Thank you, sir. So I think we have taken a lot of questions now, and I think we have run out of time too much. So I think we can send the most of the questions that we have not been able to answer. We'll answer those questions on the mail. Most probably we'll also get some answers from Ashish sir and Suresh sir, as they had another session they left. So so thank you. I would like to thank you all of the participants. Any feedback from you, sir? Can we conclude, sir?
Yeah, so thank you everyone for coming. We know, and we like to pray for everyone in the current pandemic situation for your safety. Please take precaution, everyone. And with that, I'd like to close. Anyone else would like to come, please?
Thank you, sir. So thank you, everyone. I hope that you took a lot of learning from this session, and stay connected. We are going to do more sessions like this in the future. So thank you, everyone.
So I think there's been question around recording. We will be sharing an email with the link to recording.
Yes, yes.
Sure. Thank you. Thank you, everyone. Thank you, Chakraji. Thank you, Abhishek, and the opportunity to be a part of this forum, and look forward to working with you all. Thank you.
Sure, sir. Thanks.